This webinar is hosted by the DigiNet project, funded by the European Commission, and we will have a focus on how can timber construction and digitalization boost the new European Bauhaus. The DigiNet project is funded under the European Digital Europe program. It's a coordination and support action for 2 years. And here you can see the consortium, the Technical University of Delft, Trust IT and Compla as communications and coordination partner in Italy, ICF, the Industry Commons Foundation, the European Association for Architectural Education, EAAE, and last but not least, InnovaWood. So these 3 last partners actually represent active players in the field of open science, open data, open society, architecture, building, and we as InnovaWood, the Association for Research and Education in the wood-based sector, are focusing on the wood-based sector. This webinar is hosted as a series covering all these topics of the new European Bauhaus. And the main focus of this DigiNet project is actually to create a platform that can host all the initiatives and all the ongoing projects inside this new European Bauhaus movement that was launched by the Commission in 2021. So I'm welcoming also all the speakers today. We will present them later. But Vanessa will also, I also want to introduce my colleague Vanessa from InnovaWood, and she will give an overview of the program today.
Good afternoon. Thank you, Uwe. We welcome our guests to this webinar today on how can timber construction and digitalization boost the new European Bauhaus. The webinar is organized in 3 parts. The first one is a short introduction about the role of the timber construction in the green transformation of cities and how the digital tools are involved in the whole construction process. It will be presented by Uwe Kies, the Secretary General of InnovaWood, and by myself, who also act as moderators in the webinar today. The second part consists on the presentation by our speakers, including case studies of different construction systems in their companies. The first one will be Albino Angeli, who will present the digitalization in the design, production, and construction of mass timber buildings, mainly using cross-laminated timber panels. Then Xurxo Ojea will continue presenting BIM software specifically developed for timber construction and how the structural architectural design is connected with the manufacturing process using numerical control machines in the production plants. Finally, Jannick Jahnke will present the working methodology for the design of long-span structures and mid-rise buildings using mainly glued laminated timber, as well as other innovative wood-based solutions commonly used by their company. And then the third part, and the last one, consists in a panel discussion where our guest, Anetta Kepczynska-Walczak, will interact with the speakers and also with the audience on how can digital wood construction contribute to the new European Bauhaus.
Okay, thank you, Vanessa. So we will give now this quick introduction. What actually the timber industry, what is its role in the green transformation, and how does this fit to the new European Bauhaus? Looking at the forest and wood industries together, which we basically call the forest-based sector, we can, and also applying this new European Bauhaus principles, beautiful, sustainable, and together, we can see that there are 3 main aspects. So forests are managed ecosystems that are really protecting the natural cycles and also the local climate. They play a huge role in the ecosystem, and as a whole landscape ecosystem, they are a true carbon pump. You know, trees are absorbing CO2 from the atmosphere and convert it into solid timber biomass, and which means wood is also the main renewable building material in many countries today. With this wood sector itself as a major sector inside the economy, which is around 15 to 20% of manufacturing in some countries, it represents a major employer in rural areas. And this is mainly true because the sector is dominated by SMEs that manufacture, you know, various kinds of products. And here we focus on the wood construction area, which actually is a quite high value added product made from timber. And all of this leads then to very beautiful aesthetic buildings and also, of course, interiors. We must not forget that timber is also a main part in furniture and in flooring and windows and so on. So various wood products can actually be integrated in the built environment, and which also create a very healthy and living environment. And the main reason why wood is such an interesting material now for the building sector is that compared to conventional materials, wood has this advantage that, you know, CO2 is stored in the product itself, and that it can be stored for long decades, provided that the material is, you know, used and manufactured in the right way. So if you compare the timber-based engineered products with traditional materials regarding this global warming potential, you can see that timber products can be even considered climate neutral or even climate negative building materials. So this is a very well-known building material pyramid published by the Center for Industrialized Architecture, which really compares all sorts of materials in a common methodology. And thinking then one step further, wood products, if we would include much more wood products in the built environment through this kind of long life wood products, timber buildings, all sorts of products that can be you know, integrated in the construction of buildings, then this whole value chain from forests to the built environment can become a major carbon pump. And this is this concept which is promoted by Professor Schellenhuber, who's the founding father or the mastermind behind this new European Bauhaus. So the specific role and advantage of wood-based products. What you also can see on this slide is that to make this supply chain work from really forestry to products and in the end the built environment, we also need a digitalization as a key aspect to connect all the steps in the supply chain. And thinking even further, here we are talking mainly about building industries and construction sector, but to renew our cities, we also have to, sorry, there was a skip. We also have to actually interact with all other actors in the building environment, architecture, urban planners, cities and regions, so the decision makers, and so on, which is really the Bauhaus idea, that we have to co-create across a whole ecosystem in the built environment. So here I hand over to Vanessa again to explain a little bit the specific role of digitalization in the wood construction field.
Yes, digital tools are involved in the whole construction process, from the raw material to the buildings. For example, when we harvest our forest to obtain the wood, this is structurally graded using scanners or other non-destructive techniques to determine their physical and mechanical properties, which will be used in the building design according to the building design codes. This graded sawn timber is then glued together or mechanically connected to develop new engineered wood products, which are defined for being longer and with a higher cross-section than the sawn wood. And here in building information modeling, softwares about the building information modeling are used in timber construction from many years ago. Firstly, was used mainly for connect the structural design with the manufacturing production. That is, the 3D model was defined in a computer, and then was sent, an order was sent to the manufacturing plant for shaping and machining this engineered wood product, which will be used then in the construction process of the building. Nowadays, the BIM tools designed for timber construction are also connected with other BIM or digital tools in the architectural, structural design, and also in the construction phase, and even connect with other fields such as electricity or plumbing and installations for buildings. So this is what our speakers will present today in what they do usually in their companies.
Okay. So I think we can pointed out a little bit the role already that digitalization can play to really link all these different fields in the wood sector. And just to come back again to this big picture, the new European Bauhaus was initiated by the President of the Commission, Ursula von der Leyen, and already in her opening statement, State of the Union address in September 2020, she mentioned this phrase: "We know that the construction sector can even be turned from a carbon source into a sink if organic building materials like wood and smart technologies like AI are applied." So these capture really also this connection for digital tools and bio-based materials for this green transformation. And just to close this statement with Professor John Schellenhuber, reforesting the planet and retimbering the cities, that is the goal. Timber construction is a true silver bullet for climate change. So with this, I want to welcome again all our speakers, and we'll now open the presentation. Our first speaker will be Albino Angeli from X-Lam Dolomiti. Thanks a lot.
Yes. Albino Angeli is graduated as civil engineering from the University of Trento in 2005, and he has been working in the field of timber construction, both as technical manager in companies of the sector and as a freelancer. From 2005 to 2015, he has been technical manager at Rotoglass, a company specialized in steel connectors and solutions for the building and construction industry. Since 2015, he has been working at the Paterno Group company, X-Lam Dolomiti, in which he now holds the role of chairman and CEO. He has carried out teaching and research activities at the University of Trento and is a member of the ARCA Technical Committee and ARCA trainer since the origins of this certification system. He holds several patents and has authored several scientific publications. He also is current director of Asolegno, Italian Timber Association, for the group of producers and builders of large wooden structures. Albino, the floor is yours.
Thank you very much, Vanessa, and hello, everybody. I'll try to show my screen. Okay, give me a second. Okay. Do you see my screen?
Yes, we can see it,
Okay.
but we can also see the other slide. So, Albino, you should present most probably the second screen.
Okay, I'm looking to look the other. Okay.
Yes, thank you.
It's okay this way?
Yes.
Okay, thank you very
It is
much.
perfect.
Hello, everybody. In my presentation, I was showing to you some example of digitalization in some real building site. In particular, I will give a very short overview about the company and the production of what we are doing, but I want to go immediately to showing to you some project, some real project design, produced, delivered, installed, and in one case finished, okay, like a builder, where we use for us in this moment, the more advantage digitalization that we have in this moment are available on the market, I hope. Maybe after should show me something different, maybe. I don't know. Production. We are a North Italy producer of CLT. This is our capacity, more or less 300,000 square meters of capacity. We are producing mainly cross-laminated timber. Cross-laminated timber is a panel where the lamellas are close together, and the dimension of the panel is coming from the press dimension. But after the press, the logistic issue is the mainly element that define the maximum height and weight of the panel. We are working with glue without formaldehyde, polyurethane glue, according with sustainability chain PEFC in Europe, and we have the CE marking according with the ITA. CLT is big panel from 3 to 9 layers, from more or less 51 millimeter until more than 300 millimeter, and is glued together using, in our case, polyurethanic glue and hydraulic press in the factory and CNC machinery. And here we start talking about digitalization, starting from the CNC machinery, because all the element is going in the CNC machinery, and all the element go to the site with a tolerance of 1 millimeter. For this, what I draw, if I draw well, is what I get on site. And I want to show you a lot of different examples. The design. Usually in our factory, we start to do the tendering process, okay, the quotation, using a very simple beam. In our case, is Revit, okay, and we draw all the structural element with, in some case, insulation, with windows, with everything. We start to develop this in 2014, okay, before my arriving here, because to ensure that all the quantity, all the property of the element that we draw in the phase of tender are right. What we draw is what really the company quote for the tendering process. After the structural design, the finite element model, Italian countries is a seismic region. For this, we do the seismic design with finite element model software. But this is outside from the BIM and outside from the CAD/CAM modeling today. It's another software that we are using, but outside of what we are using for to draw the building. And we're trying to define usually a CAD/CAM model. We are working with CADWork and with HSB-CAD. We have 2 different software for the CAD/CAM. And from the CAD/CAM to the installation drawing, because our system, the CLT system, is like a big Lego system on site. And with like a Lego, when you play with the children, you have the information to how you have to build the helicopter or the car. In our case, is how you have to build your house in your multi-story building. It's normally that from this, we have to produce a CLT panel on a rectangular element, master panel, where the goal is to have less waste is possible. For this, the optimization in this phase is very important. For this, again, the structural engineering, the construction engineering, together with the optimization of the production process. For example, the first step of the digitalization, our step 0.1, it was we develop our own app, where taking a picture on the QR code that you find on the label on the panel, okay, this open the EFC file with the different color on the element that you take the picture. This is very good when you download the track. You have all the element, and the charpentier and the installer can have a look exactly where have to go this element inside the building site space. It's not only CLT, because we have to talk about insulation, installation, windows, and everything, because every time we are managing timber, but really the building site is not only timber. And this is the focus of my presentation today, not only talking about the timber. And we have to define a terrace detail with membrane, with the property of this element, how you can check on site the quality of this, how you can check the quantity, and so on. For this, I want to start with an example that we are now on site in Trento, where in this project, X-Lam Dolomiti become the builder. We are doing a full turnkey building with installation, with insulation, with plasterboard, with everything, okay? And we start to develop a CAD-CAM model. And with the CAD-CAM, we import to Revit, and we build all the cladding, all the installation and everything in Revit. For this, the timber is built with is drawn with a CAD-CAM, because today there is no BIM software that can communicate very well with the CNC machinery or where we cut the timber. For this, first we build up the model with CAD-CAM, and we import in Revit, and we start to draw all the elements using Revit. Here you can see some image. This you can see the installation inside, and you can see some ventilated facade where it's with an aluminum cladding outside. You can see the image, and you can see the site. You can see some, in this case, outdoor stable element around the windows because we need some support about a metal element, how it's drawn, and what you get on site. Okay. In our case, we find installer about the installation that is working by Revit. Okay, for this is only not the architect, it's not only the engineer, it's not only the designer team, but in this case the company that do the installation real on site, they are working 100% using Revit. For this, all the file to go on site is built in Revit, and for this it's unbelievable. But you see the installer that look the pipe, look before in the tablet, and look the real. And they're doing the installation using a tablet and not using a paper and something draw on the paper. And you can see this is what we draw in the model is what you have on site. It's exactly the same. This is well on the roof, down to the roof. There is some pipe going outside to the roof. It's the design. This is the picture about what real happened on site. Nothing was different. It's more or less 100% the same. Here you can see in the model round pipe, a square aisle pipe, and you can see exactly what you get on site. For this, in this case, you see the connection, you see the hole, and you see what we have really on site. In this case, what I want to show to you is that in this moment, all the supply chain, all the actors on the timber construction have to go in this direction. Because if it's only the timber producer using SLT, using Lulam, using other LVL or whatever we want, using this digitalization instrument, but the other after on site doesn't use it and not able to manage, this is today the very big limit of our technology, and where we have to invest a lot, because a lot of general contractor and installer doesn't use these tools. We don't have the 100% advantage of the digitalization on site. This building that I show to you now is a 36 apartments that we deliver to the client finish in less than 10 months. It's not a huge quantity of apartments, not a huge project. For us, for Trento City, it's a quite good project, okay, with the developer, but in less than 10 months, it will be finished, okay. Here you can see the plasterboard, all the information. When we work with the plasterboard people, the company working there, we give this file, they extract this file, all the plasterboard wall, all the plasterboard floor and so on, have the property, have the quantity, have what they have to do, and is what we ask to our supplier in this case. This is just the project that we are now on site. I'm trying to find out some other project that we do around the world using part of the digitalization, okay, last 3-4 years. I was not able to find a lot in Italy, because in Italy, the projects are quite small and nobody are investing a lot using BIM, using Revit, using maybe ArchiCAD, other kind of BIM design. And many times they are using just to have a label BIM, but really they just build up a model. And they, for me, is the team of architect, engineer, and the people that do the design of the installation. Okay, but really they do just a model. But after, nobody follow this model. On site, nobody follow the model, and really you have a BIM design, but really not the BIM design from the design to the site to the after design. When you give this model to the client and you say this model is what we really do on site. This doesn't happen. For this, I was out of Italy, out of Europe. I was with the project that we follow in Australia, where it's normally in some countries for big project, using all the process that I showed to you before for this first project in Italy. And this is some project that we do around the world in Australia, South America, Antigua, and some other project in Italy. But what I want to show, this, for example, was a school that we built in Italy in 2018, a small school, just 5,000 square meters of school. But what I want to show to you is that the architect win the competition because it was made by a BIM design. Okay, you see the BIM design of the school. This is a very good BIM model, and they do the tender with the BIM model. When the construction company, in this case a big general contractor, local big general contractor, do the project, no one followed the BIM model that was designed before. Is what I want to explain, that all the chain in the construction sector have to go in this direction. Using timber construction is more easy to arrive to close our 360-degree the process. Using other technologies, quite a little bit more complicated. Another example is our last project that we finished in Australia. In this case, it's a university, Murdoch University in Perth, quite big project. In this case, we do all the design in Italy, but first we have a BIM model with all the installation inside and everything. So it's quite easy to export all the element and work in CAD/CAM. In this case, we developed this in CAD/CAM. You can see the bracing, the glue-lam element on the design. You can see what we get on site is the same. You see, for example, a connection, a very simple connection, where in the model you have all the element, the quantity, and the characteristic of the element, and so on. About the installation, you can see in the installation the pipe drawn in our model. You can see the picture from the site with the pipe in the same position. Okay, when you go in a very big scale project, and in particular outside Italy, I don't know what happened, maybe in Spain or in other countries, but in Italy, the company and the investor are using the BIM concept only for big projects. Okay, and here you can see the structure already finished with all the installation, but that we draw before in the right position, in the right position. Another project, here we are in 2018 in Australia, is a student accommodation. In this case, the architect gives to us a BIM model from which we export the CLT panel for the design. We develop all our BIM 3D model. There is some Finnish room made in Melbourne. But in this case, after the architectural design on site, nobody use Revit, nobody use this system. This was another example in Australia, 36,000 square meters of CLT. In this case, the BIM model was very useful because we start from the Revit. The Revit was made from the same architect that we made the project before. We know already each other. And the BIM model was made very, very well. And emphasize. And thank you to this, we reduce a lot the time on site, and we reduce a lot the waste of time and the waste of timing on site. You can see some picture about this. Okay, the last one is a 10,000 square meter office building. In this case, was the same. We assigned the BIM model. We developed all the construction drawing by CAD/CAM, using CAD/CAM, taking out from the in this case was Revit, and we developed all the construction drawing. Finally, from my point of view, I want to do a 2 minutes summary. And what we have to develop is the mentality of all the supply chain, because in the timber structural element, the timber structural sector are already ready for this changement, because we already do these things from a lot of years, because I think that the first CAD/CAM was arriving more than 25 years ago, 30 years ago, okay? All the CNC machinery is more than 25 years existing, okay? But today I'm finding on site in Italy, the windows producer that came on site and take the sizing of the hole that we leave on the safety panel, and doesn't believe that what we design is what they get on site. Okay, and this is a mentality for the construction sector that have to change quite fast. For this timber sector can do this. If you're ready to do this, we have a very big chance in this moment. Yes, we have a big chance to explain this to all the chain. Thank you very much. I'm available for question after during the meeting, the roundtable. Thank you.
Yes, thank you, Albino, for this very interesting presentation. I think you made a good point that this prefabrication and this digitalization of the timber process is really useful to speed up and to enhance the quality here. There were some questions in the chat, but maybe we take them later in the discussion session. Yeah, would that be okay, so that we can move on with the next speaker? So, yes. Vanesa, please.
I'm going to present our next speaker. He is Xurxo Ojea. He's a forest engineer from Universidad de Santiago de Compostela in Spain. He has developed his professional career in different branches of the company CADWork, the BIM software leader in the timber construction industry for over 30 years ago. Between 2005 and 2009, he worked as an engineer and technical sales professional for CADWork Switzerland, and between 2009 and 2019 for CADWork Iberica, based in Spain. From 2020, he is the co-director of CADWork Iberica and Latin America. Welcome, Xurxo, and the floor is yours.
Thanks for your invitation. I'm going to share the screen now. Okay. So I'm going to present you a tool that Albino has introduced in a very good way. And we are speaking about a CAD, CAM, BIM software specialized in timber construction. We say, what's that? What's a CAD, CAM, BIM? What's the meaning of that? It's a CAD because it's used to design. It's CAM because it's used to export for numerical control machines called CNC machines. And it's all that is designed using the BIM methodology. For that, we say that it's a BIM software. In this presentation, I'm going to try to explain the reasons for the existence of a tool like this one. Why does a technical office or a wood housing production company, for example, need a specific tool for this purpose? Or what are the specific needs of a wooden construction project that make it different from other kind of projects? We are going to answer these questions in this brief presentation. First of all, we will try to clarify exactly what a CAD CAM-BIM for timber construction is. CAD, computer-aided design, is a technology that allows automating the manual process of products design, reducing errors, gaining speed, and increasing quality. Roofs, frames, panel works, CLT, glue laminated timber structures, generating lists, generating shop drawings, all that are processes that need automated. In industrialized and modular construction, we will try to find the biggest degree of prefabrication possible. What's a CAM software? It's this kind of software allows exporting the designs to a numerical control machine. CAD will export its designs to all specific timber frame CNC machines. We will show some examples later. What's BIM, Building Information Modeling? It's a collaborative work methodology for the creation and management of a construction project. A BIM software allows to create and manage this 3D model in a very specific way, so all the agents of the projects can use this same model. I'm going to explain all this using this example. Here you can see the screen of our software, and here the example of a timber frame house. I have just activated an element of the house, a wood stud of a timber wall. It's marked with a blue arrow in the center of the screen. As you can see in the window marked with a red square in the left side of the screen, we can see directly the section, the length, and the position of this element, but the direction of its axis too. That is very important to know the grain direction of the wood. But also its color, material, over dimensions, which wall is part of, which floor, which building, with which elements it's in contact to define its ending types. For example, the joints between beams, like tenons, mortises, dovetails, for example. And so, knowing these values, we can know what its weight is, its center of gravity, its real volume. For example, how many pieces of this section there are in the project, how many walls, how many square meters of panel OSB, for example, we have on the first or second floor. What is the volume and price of the insulation for this project? Or how many kilos of steel do we have in the metal connectors? We have only to shape all this information so that we were recognized by the Building Smart Association as certified BIM software. Therefore, it's enough to slide an EFC file with BIM format on the CAD screen so that we can absorb all the necessary BIM information and begin with work. Once this BIM has been imported, we begin to work. We design to build. We add construction elements, most of them specific to timber construction, like beams, panels, plates, screws, fitting installation axes, as Albino has shown before, metal connectors, etc. All thinking about the production and assembly of the structure. This is the difference between us and a simply designed software. For the wood frames, for example, we are equipped with automatism for the design of the frames. For example, distance between studs, that depends on the dimension of the structural panel used, vertical and horizontal gaps between panels, if we want to materialize or not the insulation, etc. For CLT panels, for example, we can automatically define the division between panels, the kind of joints between them, as you can see in the screen, the grind direction of every one, the composition of every panel, 5, 7, 3 layers, for example, the quality of their external faces, And since we are talking about timber structures, it's essential for us to be able to define exactly the kind of joints between elements. Wood-wood joints, like tenons, dovetails, half-laps, etc., or metal joints, like commercial metal joints, lag bolts, screws, etc. All this information will influence the production of the timber elements ready to be manufactured by the help of shop drawing or by the help of CNC machines. Sometimes, as Albino has shown us, there are extra elements like the installations, which normally affects the elements of the construction. How? For example, some parts will have to be moved, and others will be drilled or mechanized by the CNC machine, and we have to measure the linear meters of installation, for example, of the machining hours. We already have finished the complete 3D models. You can see a HTML file created from software. And now, what shall we do? The 3D model is in my computer. How could I share all this information with all the other agents of the projects? Well, we begin. Step 1. We number each element and generate the list of materials of all the elements that we have designed. Lineal meters, square meters, cubic meters, kilograms, units, prices, all are in lists ordered by sections, materials, by walls, by height, by buildings, by stories. Even we need to know the list of raw bars we are going to need to obtain a minimum waste of wood, for example. Okay, we already have the number of pieces. Now we need to manufacture them. We obtain the exploded views, a shop drawing of each piece, fully dimensioned, with all its cuts for its manual manufacture, or a shop drawing of each wall, also automatically dimensioned, with all its layers if we are speaking about a framed wall, or a shop drawing of every panel of CLT, or even a plan of each facade or of each assembly group. And as Albino has told us before, for CLT panels or another kind of panels, we need a nesting calculation. What's that? For certain dimensions of raw and big panels, or called master panels, we will need to put the project panels into them. So the waste, it will be as little as possible. In this way, we will really know how many square meters of panel we have to manufacture, and the order to the CNC machine will be done. And of course, the assembly plans are essential. We have already manufactured the beams and panels, and now we have to put them together by the help of these general shop drawings. But there are more extra and necessary tools. We need to know, for example, for the CLT panels of the timber frame walls, which are the anchor points for the lifting in the manufacture or in the transport and uploading on site, for example, depending on their center of gravity. That's what cardboard take care of. Another extra tool allows us to work with point clouds, millions of points that comes from a 3D scanner or from a drone measurement. So we can design our structure leaning directly on this point cloud and obtain results like the one you show in the screen. In manufacturing with a numerical control machine, or CNC, we use CAM software. That is, we export the 3D model to any of the CNC machines dedicated to timber structures. There are 3 kinds of timber CNC machines for timber structures. CNC for cutting beams, like this one you can see in the screen. Machines equipped with various tools like chainsaws, circular saws, various types of milling, drilling, etc., to machining the different process that a wooden beam contains always. A second time, CNC machines for cutting panels, normally CLT panels, designed specially for machining large panels or curved, even laminated beams. A third type is called multifunctional bridge, or CNC machines for the assembly of timber frame walls, on which there are more and more in Europe. CADwork is in charge of telling the machine software where the pieces of the structure go, how to place the panels, how to make the perimeter cuts and the cuts of the doors and windows, with what tool, etc. Okay, with the finished and machine structure, it's time to load the truck, for example. If they are bars, no problem. But what happens if they are big panel CLT? There isn't so much room anymore. CADwork has a tool that loads the elements onto the truck. You only have to give the dimensions of the box, decide in which position the elements are going to be placed, if they are standing, lying down, etc., and if we want to group certain elements or not. To transmit this information to our customer or to the assemblers, we can use the HTML format. This format, files, can be opened of any device. We can add an assembly diagram step by step, and we can read the QR code of any part, as Albino has shown us, and obtain information about its position in this simple model. We need to export and import to almost any 3D and 2D format, not only to the IFC format, but to many others. The most common are in the screen. Don't forget, we are working in a BIM system, so we need to export our model to the IFC format, so all the agents of the project can use our work. We can export our model, selecting a defined level of detail. So we can decide, for example, if we want to show or not the end types are tenons, mortises, or dovetails, see if we want to show the nuts and washer of the bolts, etc. Rhino inside CADwork is a tool that allows us to embed Rhino 7 in CADwork 3D, for example, so we can take advantage of the surface model in our CADwork 3D environment. In definitive, wood construction predates any other kind of construction. It has never stopped being built with this material, and it seems that in the future it will be used more and more. Tradition and technology come together in each of the wooden projects that are built this century. Built in good is building the future for our children. So thank you for your attention.
Thank you, Xurxo, very much for this insight into the CADwork software. Yeah, I think we can really see the potential, how it's used already, but also that it can be expanded much further through more development, as you just pointed out, and that the digitalization of the wood sector can be a driving force, you know, to innovate this building. So thanks again, and yeah, I think we will also go on then with the next presentation, so that we have enough time for the panel discussion later. Thanks a lot.
Yeah, thank you, Xurxo. And now is the turn of Jannick Jahnke from Simonin. He's a timber engineer with a passion for timber who began working in the industry over 10 years ago. His fascination with wood has led him to pursue a career that incorporates both his expertise in joinery and his background in timber engineering. As a structural engineer and technical sales professional for Simonin, a French glulam manufacturing company, Jannick has found the perfect outlet to combine his mastery of precision joinery techniques with his knowledge of building structural analysis, which he gained during his master's degree in 2016 at École Supérieure du Bois in France. Jannick, thank you for being here today, and the floor is yours.
Thank you everyone for attending this meeting, and especially Uwe and Vanessa for organizing. So I will present you today a presentation about timber structures. We'll start with a short company presentation, then we'll go on to the second topic of the long span structures, the mid-rise building, and the short conclusion. As an introduction, I work for Simonin, a French-based glue manufacturer. So the company is based in the eastern part of France since about 50 years and was founded by 4 brothers. The company today employs 130 people and uses CNC machines and, of course, CAD work as a drawing software, which has been presented just before. These are the things made by the companies. So we have today an office with structure engineers, draftsmen who work with CAD work for the drawings and other softwares for the CNC programming. Then we move on to the manufacture of glulam, the CNC machining, the logistics and assistance on site of installing these structures. Simonin is a company which is based in France and exports all over the world. Here I've got a few examples of projects which have been built in the past. When you do such kind of projects and especially ship them all around the world, you expect the materials to be of a quality and to last where they should and how they should. That's why research and development as well as quality control are central items. Of course, fire tests, which you can see in the upper left corner, structural tests, which are destroying some test trusses to see the resistance of the connections and of the timber elements, and the glued-in rod connection, RESIX, which has been developed by Simonin, which is also tested and under technical assessment. Glulam is a material which is used since quite a lot of time, and the production process is following. We have raw boards, timber boards, which come from a sawmill, which are then finger jointed. That's what you can see on the left side to make a lamella, which is a long strip of timber. And all these long strips of timber are glued together in, for example, a high frequency press, which you can see here, to form a beam. For curved pieces, the process is pretty similar. You use thinner lamellas, which are then bent, shaped, and glued to get the special shape and curve. Here we've got a picture of the manufacturing hall with 2 CNC machines. Pretty similar to what Xurxo showed before. We can machine straight beams, curved beams, double curved beams, twisted things, and also round columns. These are done on the right machine and straight beams on the left machine. This brings us to the things that can be made with this raw material. We'll go from the raw material glulam to the structures at the end. So we can do sports halls, multi-story buildings, which we'll see later, and special shapes, which you can see on the right side. Of course, in timber, there's always one topic, which is fire. That's the first question which is raised usually. And in fire, there's 2 things to remember. There's the fire resistance, which is counted in minutes, and the spread of flame is how a material behaves in case of a fire. So for fire, we have on the left side, the fire resistance. Here we can see a beam on the left side, which is a timber beam and creates a charring layer all around. This charring layer protects the inside of the beam and makes that it will resist during several amounts of minutes or hours as designed, whereas a steel beam, which you can see on the gray picture, will start to get wobbly and fail. It is now supported by the timber beam, which remains in place. On the right side, it's something else. It's the spread of flame. It's the Euro classes, which say how a material behaves in case of a fire. So if, for example, A1 is steel, which is non-combustible, and timber, which is between D and B, according to the treatment that you apply on it. So when you apply that on a building, you've got, for example, a timber floor and a timber ceiling. You want this timber ceiling to resist so that when you have people on top of it, it should resist during, for example, 1 hour. That's what you can calculate with the charring layer on a timber beam. And then you've got the cladding on the wall, where you're more looking not for a resistance, but a spread of flame. That means how will it react in case of a fire? Will it ignite or not? And that's something we can achieve with treatments or natural products such as larch or the timber species. From fire, we will also go to a type of connection, the glued-in rods, which is a type of connection which is embedded into the timber. As we've seen before, when you have a piece of steel, in case of fire, these ones are losing their resistance, whereas when you embed the steel in the timber, you use the insulation properties of the glulam and of the wood to protect the steel connectors inside of the material. Other advantages of the glued-in rods are the pull strength, their water resistance, and the versatility of uses you can have with them. So Simonin uses them quite a lot for export purposes, because we can produce small elements which fit into a container and can then be shipped all over the world to a final destination and assembled on site using simple steel screws, steel on steel. Other uses of this technology are wood and concrete, using the right material at the right place. So we have glulam ribs and a concrete floor poured over it, or CLT as manufactured from X-Lam Dolomiti with the connectors inside and then the concrete slab poured on above. Let's move on to the first topic, which are the long span structures. As in every process in the timber industry, everything starts with the 3D model and the BIM software. So all pieces are drawn in the software. Then from there, they're exported on the CNC machine, what we can see on this part, where we estimate the time of machining and simulate everything. Once the simulation done, we go to the workshop. Here we have a CNC machine with the capacities. Everything is programmed before and executed on the machine precisely with a precision of about 1 millimeter. Once every single piece is machined, we move on in the workshop to the part of the assembly, where we have pre-manufactured pieces. That means we will arrive on site with elements as big as possible, as shown with X-Lam Dolomiti, with prefabrication in order to have a good precision. That's what we aim for. And once we assemble everything, we can get structures with a span of up to 80 meters very easily. This span can be achieved with curved structures. From a technical point of view, they are very efficient to cross long spans. So they have a lot of horizontal push on the concrete foundations right and left. That's why they needed to embed steel rods in the floor to hold back the right and the left foundation, to take all the horizontal efforts brought in by this structure. On the right side, we can see the steel connectors, which allow to assemble the 12-meter long beams, which were shipped by container and assembled on site to get the 80-meter arch overall. Then you can say timber construction has nothing new, and that's what we can see here. That's a building of the 1980s, which has also an impressive span, spanning from right to left with more than 40 meters. Here again, the curves, they are really useful to have long spans and a lot of compression on the right and left side. This can be used in sport halls, such as basketball halls. This one is in Lebanon. This building was also made out of timber arches. And here we have an example. This building burned down, at least it didn't burn down. There was a fire inside. The timber has resisted during the time that it needed to resist because it has been designed to. And you can see small steel strips of the steel sandwich panel hanging from the ceiling, but the main structure was still standing and today has been replaced by trusses. These trusses are another useful way to span the bridges if you want a flat roof or almost flat roofs, we can span 38 meters using 2 trusses of about 20 meters, which are jointed at the center on site. Another example is this one for a fire station. So firefighters really love timber in some places because the resistance in time is pretty impressive with 1, 2, or 3 hours, according to the design. That's the finished structures with a span of more than 30 meters. We've got other examples of uses to have long spans with triangular structures. They look really lovely once you have installed a glass roof on top of them. Here we can see the connections, which are all done in the factory and off-site. So this is made in the factory, all assembled, shipped as long elements, and assembled on the construction site to form one truss. And here we have the finished result with the lighting on top of it. Here we have something else with, again, 2 trusses assembled for transport reasons, for a horse arena. So now we've seen that we have many examples of buildings with quite long spans between from 20 to 80 meters. Above 40 meters, the curved design is pretty helpful, and about 40 meters can be handled with trusses. Once we have the span, there's another topic, which is the overhang. This is also sometimes called cantilever. So here we have a structure which has 15 meters overhang from the post to the end, and which should resist the vertical forces which are going down, and also the uplift, which is an impressive thing to calculate on structures, because all the connections have to be calculated for vertical loads downwards and vertical loads upwards. That's the inside of the building. Here we have another example of trusses, and these trusses need a moment connection to hold up. That means we have one support on each side, and we need to create a moment connection with the glued-in rods where the vertical and the horizontal part meet, so that it creates one continuous beam which meet at the ridge. We can see the moment connection right on the top left corner of the picture. Once you have a span, you can also build bridges up with timber. That's another solution. Here we have a footbridge crossing a river with a high voltage cable embedded in the bridge. That was the reason for the construction. The government needed to pass the electric wire from one side to the other. So one solution was to dig under the river or to cross the river with the bridge. So they've chosen the bridge, which is also good for pedestrians. Durability in timber is another topic. That's why the bridge is covered, and covered items will have a long resistance and long durability. Here we have an example of a bridge which is designed to support trucks. So it's crossing a highway, and you can drive with trucks on top of these bridges. Now we've seen structures which have horizontal spans, and we can also apply the same thing vertically with observatories, which have a height between 15 and 30 meters. And the idea is pretty similar. Instead of being horizontal, the beams are vertical and support the same conditions of stress with bending. Here we have an example in Italy. It was built for the World Cup in Italy in the 1990s, still standing, a large structure. Today it's not this color anymore, it's gray, but it's still standing and doing fine. So if one day you go to Napoli, you can see that in front of the football stadium. The other topic were the mid-rise buildings. We've seen the towers, and now we'll see this thing applied to other structures. So we're going to make a difference between the medium-rise buildings and the high-rise. Sometimes people talk about high-rise, but 12 to 39 floors. There are a few buildings in timber going above 10 floors, but usually we're above 5 and 10. That's something where timber is really used, and that's common today in the industry. The ways to build these projects are different depending on the height and the construction methodology. So we've got the exoskeleton made out of glulam. We've got the CLT, as Alberto has showed it before in the presentation, posts and beams, and also sometimes concrete centers, which do the stability of the building. One typical way to have the floors made is with CLT, as showed in the first presentation. And then we've got the walls, which can also be made out of timber frame, which makes them a bit lighter and thinner than the CLT versions. I found a map of high-rise buildings or medium-rise buildings which have been built over the past years or which are in projects. As we see, it's something that starts to be common, and I guess in a few years we're going to have some more spots all over the world. One example could be the police station of Monaco. It's not very high, it's only 4 floors, but standing on a timber structure that is more than 10 meters high, to have a road passing underneath, because in Monaco they have real huge space problems. So they start building on the roads, and that's a temporary police station that will be used for a few years during the old one is refurbished. Simona has participated in the floor structure or the ground structure, which is built entirely out of glulam, with glued-in rod connections and a fire resistance of 90 minutes. That has been achieved with the charring layer and an additional protection with a timber panel where the steel connections are to protect the glulam with an additional layer of timber at these places. Here we've got an example of the beams which are in the factory, with all the glued-in rods which will be injected at all these places to have a moment connection and stiff portal frames. One portal frame can be seen here and installed on site. That's a picture of Ossabois, where they've produced the timber modules which were then installed on top of the structure. Another example, again in Monaco, usually mid-rise buildings are used where space is rare, so this is a good place to be. Monaco, they are now building another one, which is under construction with a post and beam skeleton. A bit like the Treat in Norway, which was one of the first ones. This was not built by Simona, and all the bracing is done with timber beams and steel connection plates, as you can see on the right side. It works a bit like the trusses I showed earlier. You can use the trusses horizontally, and you can use them for bracing vertically. That brings us to another project, which has an exoskeleton. All the outside is braced with timber. And that's a bank in Dijon in France. So we have bracing of the facade done with timber and concrete staircases, which are used also for bracing the overall building. The overall building is made out of a timber structure, timber beams, and some CLT slabs on top. Here we can see what has been showed before. All the connections are designed on the computer and installed on site. Here we've got all the steel connectors on the left picture, and also all the holes for the ducts and pipes, which are made in the factory on the bottom right picture. That was the building under construction and the inside once finished. Now we're going to pass to other types of buildings. So here we have an airport in Quebec where timber has been used as a facade. So the timber beams are hanging from the top and supporting the whole glazing of the airport. We can also build whole airports out of timber. So any size of building starts to be used today with this material. The first picture of my slideshow was the French pavilion, which was used for the Expo in 2015 in Milano. This was a nice building. It has won the first prize of architecture of the show. All made out of timber with 3 floors. So I would not even call it a mid-rise building, just 3 floors. And it has something special. That means we needed to have 2-hour fire resistance so that the upper floors and restaurants could be evacuated in case of fire on the lower level. Now we'll go to examples of beams and projects which are achievable with the material. As you see, with tight radius and special shapes. That's something we can do with timber. Here we've got double curved beams, and we can also do hybrid beams between oak and spruce to use the right material at the right place. So I hope this showed you the versatility of all the kind of uses we have with this material. And I guess there's a good place for it in the next years of construction. Thank you for your attention.
Thank you very much, Jannick, for this super interesting presentation. I think just with these 3 presentations today, we had a great overview what timber can really do, what timber has, as potentials for the future. And Jannick, yeah, you showed many different projects, even a global map. So there is definitely a timber boom you can see coming. But yeah, I'd like to discuss now with all of you, what are your thoughts on this and how this actually can be fostered more through this idea of more collaboration in the supply chain, more collaboration between different sectors. We have to bring all the people together and convince them that timber and bio-based materials are, let's say, a future solution. So before we start with the panel discussion, yeah, maybe Vanesa, you can also introduce our 4th guest, Anetta Kepczynska-Walczak from Poland, and then we go in the panel discussion. Yeah.
Yes, sure. Thank you, Jannick, and thank you, Anetta, for being here today in our panel discussion. Since 2016, Anetta is a professor at Lodz University of Technology in Poland. She is the head of the Department of Digital Technologies in Architecture and Urban Planning. She holds a PhD in Architecture from the University of Stavanger in United Kingdom and a Master of Science in Architecture and Urban Planning from Lodz University of Technology, also in Poland. Currently, she is the leader of the BIM-Head European project and of the Polish language BIM dictionary team. And between 2008 and 2010, she was also an advisor to the director of the National Heritage Board of Poland. So Anetta is an expert in BIM modeling in architecture, and for sure she will lead this panel discussion with our speakers and also with the audience. Anetta, the floor is yours for your presentation and also for providing questions to our speakers. Thank you very much.
Thank you, Vanessa, for the introduction, and thank you, the organizers, for inviting me. First of all, I would like to also thank the presenters for the really amazing stuff that you delivered today and showed, and a lot of pictures that tell more than words. So the audience was, I can see, very engaged from the start. So I found the first question in the audience. It was by Oliver Jahnke, and I guess it was at the time when Albino showed buildings that were designed in a software, and they already looked really catching. So the question was, how much time requires the planning and drawing of such a building, including every small hole and connection. You showed a lot of holes and connections, and you pointed out this value of digital twin, Albino. So I guess it was really grabbing the audience by that. So the question is followed by how much time requires building it off-site and then on-site until you can hand over the keys.
Okay, really the timing that we need to design it was just few working weeks of technical people. I don't know exactly, but really from our experience and the experience that have this installer that do the installation, you save 3 times the time that you invest, 3-4 times that the time to invest to design it. On site, you save a lot of time because if you see the statistic, the building site have more than 55% of wasting time on site, where the industrial sector have less than 10. They're talking about 6-7%, wasting time on site. For this, when you have all this information, you find already the hole, you find already the space already designed by the CNC machinery, you save a lot of time and a lot of cost. For this, the investment that you do in the office, you have a return of this investment 3, 4, 5 times on site.
Right, I guess that it is answering the question for Olivier. So next question is, I think, to all presenters, so it's up to you who can grab it. It is, what would you say? Would you say that CLT is recyclable, reusable as a material, considering impregnation, etc.?
Okay, about the CLT, usually 95% of the CLT that we deliver from our factory don't have impregnation. It's natural, completely natural, because it's like a brick wall that you go and close with insulation and plasterboard. One of the future, is not future, have to be now, point is design for disassembling, is a very strong point. We already do 3 design for disassembling. And when you design for disassemble the structure, really the CLT, you can reuse 100%. In our goal, I have already an experience in 2009 when I disassembled an existing very big facade. And with this panel, we built 3 houses of the carpenter that do this job. Okay. For this, in our idea is you can disinstall, you can disassemble, you can do again a nesting. Of course, you have maybe not 10% waste or 5% waste, but you have maybe 30-40% waste because you have to cut in small pieces. Okay. A part you can rebuild new houses. Another part you can only reuse in the industrial sector to produce panel for furniture, for example. You can reuse for do insulation. You can reuse to do many other things. Finally, if you're not able to reuse in the 1 step, 2nd step, 3rd step, you can just emit again in the atmosphere using producing energy. But this has to be the last step after 2 centuries. Okay, but for 2 centuries, have to be a carbon tank.
Mm-hmm.
Yeah, thanks for this thought. I think I would also like to hear the opinion from Jannick and Xurxo about this point.
I totally agree with Albino. All the products such as CLT, glulam, which are really based on raw and solid timber, can be reused in all the other stages as Albino described. So they are the first step of transformation of the timber, which allows to be used in all the future steps again. And this applies to CLT and glulam.
Yes. It all involves BIM, building information modeling. Yes, what we are talking about, I mean, digital technologies, not only BIM. And the question is just about interoperability between software. Xurxo, you showed the diagram with many software that is somehow well needed to reach the goal that you have, and also in Albino presentation, and also somehow not directly in Jannick, that we are aware that it's not only one CAD or CAD-CAM software or one BIM software that will do the job. So are there any drawbacks or some kind of lack of flow in the chain of production, the design itself, before it comes to building site?
In my experience, the bigger lack of information is, and I will answer in somehow to another question about static model. Okay, the transfer between static model to the production model is not easy. It's not answered for the moment. That's one of the wake points of this cycle. So the static model is once, and normally they are designed before the beginning the production. When you design the static model and you try to transfer it to the production one, the production model, there are some lack of information. You have to more or less redesign the project again. Even if you try to work with EFC, it's not easy. So I think this is the weakest point of this process. One time you begin the production, in my experience with all the companies that are working with that, one time you begin the design for the production, the lack of information is minimal, very minimal, because you are designing for production. You are not designing only for the design. You are designing for production. So what you design is thinking in the CNC machines, for example, or thinking in the shop drawing if the assemblers are working by hand, for example. So I think the weak point is between the static model and the production model. This is the weak point of this process.
Mm-hmm. And what are other speakers' experience in this regard? What are your reflections? Albino?
But for example, today in our company, the static model and software are completely separate from the BIM design and CAD/CAM. Usually we build up the model in CAD/CAM or Revit. We export to the software. Okay, we are working with 2-3 different software depending on the countries and the complexity of the building. Okay, if it's a normal houses, small houses, or a multi-story building, or a glulam, very big glulam structure, we do the fine detail model completely outside to the BIM. And after we go into the model, we modify some element. If it's not verified, and we define the connection and everything. Today is another step that all the software have to do, I think.
Mm-hmm. Okay, and Jannick?
In the industry 10 years ago, we were still passing PDF files from one to the other. And in my opinion, things have changed since then. And as Xurxo said, with the IFC models, things are getting better. They're still not perfect, but there's some progress. I can see it.
Mm-hmm. So what would be the kind of an ideal candidate to work at your company on design? What skills does such person should perform to be employed and join the team? Yeah, so
Albino?
Albino.
But first skill is a very big passion for the timber construction. First, because if somebody have a good passion, a very strong passion for this material, you can learn everything. Second, usually we ask BIM experience or BIM knowledge or in Revit or in other. Third, experience in the timber sector, but many times we don't find it. We start from zero in the timber sector, but with passion and with knowledge about software, nothing is impossible. Third, the language is very important.
Mm-hmm. Okay. Jannick, yes.
Works a bit everywhere on the world, so we have also employees coming from different countries, so with different cultures, and in my opinion, passion and interest in the material is something very important to have, because timber is a living material and with quite lots of complexity compared to steel or concrete, which are homogeneous materials.
Mm-hmm. Okay, thank you. And Xurxo, from your point of view, because you have a lot of experience also, and you showed us beautiful models.
For working in CAD work, I think you must love computers and timber structures. That's necessary, and you must be flexible. You must help a customer to work with exporting a CNC machine or presenting CAD work, for example, in an English meeting like this one. So you must be really flexible. Okay, this is the two things more important, I think.
Yeah, but I'd like to add a little bit more, because we are discussing this question of skills and do we have the right people, and how do we actually train, you know, the people in the future. So what would you suggest? What could be, you know, improved in universities or improved in you know, studies and so on, to get you know, people who can work on this complexity and on this challenging material?
For me, well, I speak about my experience in our Latin markets, Spain, Portugal, and South America overall. Okay, we need professional carpenters. We have university people that knows the material, but we have no professional workers. We have problems because some technical office want to design projects, but there are no people that can build them. There are no professionals in the ground. It means in the construction of the buildings that we design. It's our weak point
in the construction sector, yeah, for skilled people that really understand this wood building technologies.
Yes, yes.
I'm just putting an example experience in Italy. In Italy, all the instruction sector, engineering, architectural, and everybody, they forget the timber construction for 1 century. Okay, now they start to implement a little bit, but if it is 200 hours for concrete and 200 hours for lesion for steel, timber is maybe 50. Okay, I was very lucky because I studied in Trient with Professor Piazza. Professor Piazza started with timber design course more than 20 years ago, and I made the same hour for timber and for steel, but it's completely voluntary. Okay, and this was what today it's happened in Italy, but in many other countries, is where a client, a developer, go to the architect, go to the engineer, and say, okay, I want to build by timber this 7 floors building. The answer is, why timber? Much better concrete, much better steel, because they are not able to design it. Looking only the development of the software. All the software are very developed in steel, in concrete, and they start to implement something about timber. But it's because the market is going very low. The knowledge is missing, and not only the carpentry. We have the same problem in Italy for the carpenter that it's like we are Latin in Italy. Okay, for this it's the same problem, but we have problem with the technical people. There is some young people that have training, but all the people from 30, 35 years old until 60, 65, they have no knowledge.
I totally agree with Albino. That means 15 years ago, also in France, saying I want to study or work in the timber industry, it was something like impossible, or there were 1 or 2 schools accessible for that. Whereas today, it gets people, the trend, they get more and more in that industry. Schools are opening, so we might get some more people in the industry during the next years.
So we observe the gap in at the moment, and I think it's not specific to one country, but generally in many European countries we have this gap that first was observed with heritage buildings when the time for conservation came, and it was now skillful carpenter to deal with the problems, and there were very specific problems that not mass production but very individual elements to be taken care of. And nowadays, yes, at least in I would say East and Central Europe, what we lack is specialists, people with skills. Yes, we have a lot of people in academia, but skills are gone, so they should come back because they are needed. And I guess it is kind of a future probably for young people who are looking for the way what to do in life, because AI would not replace them so quickly as in other disciplines, because hands are hands, and you need, skills that are not replaceable by well, machines, of course, CNC, but still we need people, we need humans, yes, to work on them. We have a good question. Yes, this is a question. Can I read it? It's a very long question, but it is from Albino Angeli, if I pronounce correctly. Considering the increasing interest in mass timber construction and its potential for widespread adoption, one factor to consider is the limited availability of wood as a resource. As we move towards scaling up timber-based buildings, how do you envision addressing the potential challenge of material scarcity? What strategies can be implemented to ensure the long-term sustainability of timber construction in the face of limited timber resources? So, long question, but very strong one.
I can try to answer, because we are doing a very big investigation project in our company about this issue. It's normally that today the concrete and steel sector have a big dimension, timber construction, and a very small dimension in terms of number. And in this moment around the world, there is a lot of forest not managed and not used. For this, we have maybe potential to increase 2, 3, 4 times until to arrive to this problem. Because, for example, I take an example, all the Middle Italy, we have a lot of species, but there's not spruce or not pine or different other species that are not used. And with CLT, you can use every kind of species if you want, and if you do some research. For example, today we are developing an investigation project for using fast-growing species. There is a lot of fast-growing species with low technical characteristic, but you can increase using some different treatment. Okay. And we are developing the new CLT panel, new glulam beam using fast-growing species. Fast-growing for me is mean diameter 30 centimeters of the tree in 7 years, 8 years. Okay. For this, you can do plantation. You can do very strong plantation and use for construction fast-growing species coming from plantation. This could be an idea to develop the sector. It means standard. It means production machinery and everything.
Thanks a lot. And Jannick, what
yes.
you answered on this question?
In my opinion, we need to create a demand for timber. Today, we've got lots of forests which are not managed, as Albino said, and there's no interest. The timber price, buying a tree is like worthless in a forest. So once we create a demand and create value for this raw material, there will be interest and financial interest also to plant it and to use the forest, which is not used today. And Albino, when you said fast-growing species, you're talking about radiata pine, eucalyptus, or
others. It's a little bit secret in this moment, but others.
Sorry,
not this one.
Yeah, this plantation forestry, that is definitely a topic that is has to be addressed more and more. The debate about is there enough timber or not is not very easy, because it depends on what kind of angle you're looking at it. From a forester side, you can say, yes, there is more stress on our ecosystems today. But as you already pointed out, there is actually enough timber in the forest that is not used in the right way, because there's no market yet. Yeah. So it's very interlinked. That's what I wanted to point out with our graphic, showing that we have to link actually all the steps in this supply chain, even back to the forest, to understand really what is happening and how the value can be created. So I liked a lot what Albino just said. Other timber species, new types of products, research and development into new solutions that actually use different types of timber or different types of species. That would be really, I think, a big step forward to address this problem. Yeah.
Yes, I can see that the audience is really very involved, and a lot of questions are rising. So we are almost out of time, but maybe this one question, because there are a lot of issues is about the lack of resources, but also about the sustainability, etc. So the question is, what kind of glue is used in CLT nowadays, and are they considered as sustainable material? What is the plan if in the end of their service life, is there a toxic substance released if they are to be burned by the end of service life? Albino, you are muted.
CLT can be produced using different glue. Mainly in Europe, the producer is using polyurethanic or melaminic. This is the two way. In our case, we are using polyurethanic, but what I explained today is very valid for one and for the other one. For example, here in Italy, we do like with timber association, we invest 100,000 euro to the investigation. We burn a lot of glulam with polyurethanic, with melaminic. For the CLT was the same. Really, the quantity of the glue that there is in the middle of this material is very low, and from last month, it's permitted in Italy to use this kind of waste like combustible material. Okay, for this, absolutely, the quantity of the chemical material is quite nearly to zero, very nearly to zero.
In glulam or in CLT, you've got 40 millimeter timber and less than 1 millimeter glue in between. That means it's maybe 1% glue on the end product.
And maybe just one last question. There's a lot of last questions, but I can see that really towards the reality, because the reality is not only big companies, but also small and medium enterprises. So the question is, from your experience, observations, maybe studies, are these technologies used with BIM tools in small and medium enterprises? How is it implemented in the construction sector? This is the question from Ricardo Gonzalez.
The small building today, from my point of view, the investment that you put in the BIM modeling, everything many times is not paid after on site, or what the people is thinking. Really, from my experience, we are working the same way for all kind of building, and we are convinced that you save time, you save wasting time on site. You don't have extra cost after. For this, the way have to be this, and all the company, from my point of view, have to invest in this way. Today, with the Next Generation EU, with the Bauhaus program, there is a possibility for the small company, small size company, to invest, and they have a help for European Commission to invest in this way, to develop and to use software for the small and normal job.
In my experience, I have some customers that are 2 or 3 people in the company, not more. So what they do, don't forget the timber frame walls. We are speaking about CLT, for example, but timber frame walls are easy to construct, but always they try to do off-site. They try to do in the fabric, in the industry, and only do the assembly at last. But there are companies of 2, father and son, for example, or 3 people, are a lot of them that we are using BIM softwares, CAD/CAM softwares, and hand machine for cutting wood by hand, not using CNC, for example. Or in another way, there are some companies that are offering the service of cutting wood for little companies. You don't have to have big technology to use. You can send the 3D file. Another company is going to cut the wood for you, and the wood come back, and you can build the roof or the house in timber frame or even CLT. with no need of big effort.
Yeah, thanks for this point. I think it's clear that actually this digital tools can maybe become more accessible to more companies. So Albino, you also said this is a challenge when you work together with a lot of contractors in the construction site. Do you see that there's some progress, or do you think that actually this timber manufacturing can help, can make this easier in the future? What is your opinion?
I'm sure that we can help a lot the sector, because if we are able to help the sector, because in each building that we find, there is a general contractor, and the general contractor many times manage a lot of small building or big investment and so on. When the general contractor understand that save money, save time, and have more profitability on the site, they will change from concrete or from steel to CLT. Okay. For this, if we are able to convince a lot more general contractor, a lot more investor, developer, and they understand that what we design is what you get on site, what we give like pricing is exactly the same when you finish the building site. There's no extra cost, and it's very easy to do budgeting and so on. This is the way, because they can say, okay, with using timber, I have certainly cost, certainly time, no waste, safety issue solved before, and so on, so on, so on. There is a lot of advantage, lateral advantage using this technology. But we have to drive, the timber sector company have to drive this change.
Okay, thanks a lot to all of you, I think. If there's somebody wants to make another comment or a last point here. I think it was a very interesting seminar, webinar. Thanks a lot for your participation. And yeah, we hope to continue this series. There will be more webinars also on timber, but thanks a lot for your contributions. And yeah, thanks also for all the participants. I think we had more than 150 participants today in the webinar. So a great success. And yeah, let's hope we make this timber revolution happening and that we meet again in the future and see more of these results.